Hello and welcome back, wonderful people. Today is Kubernetes Day 4. Yesterday, we moved beyond single temporary pods and learned how to manage our application with a smart, self-healing deployment. You now know how to tell Kubernetes, I want to have 3 copies of my app, and if one of them crashes, you'd better replace it. But here's the next big challenge. How do our users actually talk to our application? If you have 3 running pods, each with its own randomly assigned IP address, which address do you give the user? And what happens when a pod fails and a new one is created? The new pod gets a brand new IP address, and your user is suddenly met with an error. The problem is that pods are designed to be ephemeral. They are temporary and can disappear at any time. Think of it like this. Your application's pods are like employees in a large company. You don't give a customer your employee's personal cell phone number because if that employee leaves or gets a new phone, the customer can't reach the company anymore. Instead, you give them the company's main phone number. In Kubernetes, the company phone number is the service. A service is the crucial, stable gateway that shields the user from the ever-changing temporary nature of the pods behind it. A service is a Kubernetes object that provides a single, stable IP address and DNS name for a group of pods. It acts as a permanent front door for your application, automatically distributing incoming traffic to all the healthy pods that are running behind it. The real genius of this system is that it completely decouples or separates the application's public access from the lifecycle of its individual pods. Pods can crash, scale up or down, or be replaced by a rolling update, but the service's IP address and DNS name never change. So, how does a service know which pods to send traffic to? It's not magic. It's through a foundational concept of Kubernetes, labels and selectors. When you create a deployment, you give its pods a specific label, like app, my hello app. A service's configuration contains a selector field that says, I will manage any pod that has this exact label. This declarative, rule-based connection is how the service dynamically discovers its healthy endpoints. As soon as a pod is created with that label, the service adds it to its internal list of available destinations. Services are not one size fits all. Kubernetes gives us 3 main types of services to handle different exposure needs: ClusterIP, NodePort, and LoadBalancer. ClusterIP is going to be our internal-only extension. This is the default and most common type of service. A ClusterIP service exposes your application on an internal cluster-only IP address. It is not reachable from outside of the cluster. Think of it as an internal phone extension at a large company. It's perfect for internal application-to-application communication, such as a web front-end pod needing to talk to a back-end database pod. The front end simply needs to know the database's stable service name and port. The ClusterIP service handles all the complexity of finding the healthy pods for that database, so the front end never has to worry about changing pod IP addresses. NodePort is our external-facing shared port. This is the service type we'll use most often for our projects. A NodePort service opens a specific static port on every single worker node in your cluster. This allows you to access your application from outside the cluster by using the IP address of any of your worker nodes, plus the static NodePort number. For example, your NodePort service might open port 30007 on every node. To access your application, you'd go to http node IP address :30007. Kubernetes guarantees that port 30007 will always route traffic to your application, no matter which pod it's running on. This is great for development and demonstrations on a local cluster like Docker Desktop, as you get a consistent way to reach your application without needing a complex cloud setup. LoadBalancer is going to be your dedicated public hotline. This is the service type designed for production. When you create a load balancer service, it automatically provisions a public-facing load balancer from the underlying cloud provider such as AWS, Google Cloud, or Azure. This load balancer gets its own dedicated public IP address and can intelligently route external traffic to your service. This is the standard for making your application publicly available on common internet ports like 80 for HTTP or 443 for HTTPS, and ensuring high availability across multiple nodes in a production environment. The cloud provider handles all the heavy lifting of managing the external traffic, and your service simply provides the stable link to your pods inside the cluster. Now let's take a look at the full picture, a deployment and a service. This is where the magic of Kubernetes truly comes together. The deployment and the service work as a team. The deployment's job is to manage the lifecycle of your pods. It ensures that the correct number of pods are running, it handles rolling updates, and it provides self-healing by replacing failed pods. The service's job is to provide a stable access point to those pods. It uses labels to discover its pods and acts as a load balancer for traffic. Together, they form the fundamental pattern for building scalable, resilient applications on Kubernetes. Your users don't care that pods are ephemeral. They just care that the service's IP address or DNS name is always available. Up until now, we have been using the declarative method for our services and deployments. But for quick testing and demonstrations, Kubernetes provides an imperative command to create a service for an existing deployment. This is not the recommended method for production, but is perfect for learning and for our homework. The command is kubectl expose. You simply tell it which deployment to expose, what type of service to create, and which ports to map. The command line tool will then automatically create a service resource that links to your deployment based on the labels and selectors. We will walk through this exact command in today's homework, solidifying your understanding of how services work in practice. Today's mission was to understand that a service is the critical component that gives your ephemeral pods a permanent identity. It's the stable front door in a world of constant change. With this knowledge, you're now equipped to not only deploy applications, but also to make them usable and accessible. This is a huge leap forward in your Kubernetes journey. For today's homework, you'll want to start by grabbing the Day 4 homework document linked below. You will then test your understanding by answering a few review questions. After that, you'll practice exposing your application using NodePort. As always, if you have any questions, feel free to comment them below. That concludes everything for Day 4 of Kubernetes. Thank you so much for joining me. Be sure to like, share, subscribe, and sign up for notifications so that you can continue on this sprint with me. See you for Day 5. Hello, wonderful people. My name is Janelle, and thank you for going on this journey with me. Are you feeling a little lost in the world of tech? Cloud computing giving you the blues? Programming languages are all Greek to you? Artificial intelligence making you question your own intelligence? Well, you've made it to the right place. Welcome to 6 weeks later, where together we will master information, one focus sprint at a time. If you're over 40 and ready to understand the digital world, you're in the right place. And as always, don't forget to like, share, and subscribe.